Hello and welcome to Empowered Learning. In this video you will learn how to take a set of data, enter it into your TI-83 or 84 calculator. Then from that point we'll learn how to create a scatter plot with this data. And then finally we'll learn how to create what's called a linear regression line or a best fit curve line that best models our data. So let's go ahead and get started. The first thing that we want to do is enter in this data. So to do that, we need to go to the stat area. So we'll press this button here called stat. And then from there, we will need to go to edit. And here, if you noticed, I already have the data values in here. But once we're in here, I'll use column L3 sort of as an example. If I wanted to enter in a value, I would just say 16.6 and then enter. And then, of course, if I want to do the next, I just say 16.9 and then enter. Okay? So it's really just that simple. If I want to get rid of data value, just hit delete and delete. And so you just need to do that to get all of your data values in. And then once you have completed that, then we can go to second mode or second quit. Okay. Now from here, what we want to do is now tell the calculator to create a scatter plot of this data. So in other words, we actually want to take these data points as they are and plot them on a Cartesian plane. So the first thing that we see is that we need to go to stat plot, which is up here above the y equals button. So we'll press the yellow button and then the y equals. And then from there, what we want is option 1. Okay? And we want option 1 because we're trying to do a plot of columns L1 and L2, and we want to turn it on. So we're going to hit enter or 1. You see that it's currently shaded as being off. What we want to do is make sure that it's on. So you see that it's blinking on, so we just hit enter to turn it on. And of course, the type of plot we want is already highlighted here, the scatter plot. We have other types of graphs here as well. So we have XY line, we have histogram, we also have box and whisker plots as well. Okay, so of course we want to make sure that we're on the scatter plot for this one. If you notice, our X list, or the list where our X values come from, is going to be column L1, and the Y list will be column L2. If we wanted to change that, we could just come here and change it if we liked. Okay, so I press clear for that to put L1 here, but let's say we wanted L3. So to find L3, we need to find where L3 is, and if you see above the number 3, there is an L3 right there. So since it's in yellow, we press second and then that, and you see how we have L3 there. Since we just want L1 for the X list and L2 for the Y list, we're just going to keep it as it was. So do that, and then the number 1 gives us L1 there, because we see a L1 above the button 1. All right, so now what we need to do is go to our window to make sure that we're going to see this properly. And so to make my point here, if I go straight to graph, if you notice, I don't see anything. And part of the reason I don't see anything is because if we look at our window is for the X values, -10 to 10, and then for the Y values, -10 to 10. If we look at our actual data, we see that we have something totally different going on here. For our X values, one of the things that we see here is that if we look at this list, the smallest X value that we have is this one, 12.9. The largest that we have is this one, which is almost 20. So here a safe range for our X values would be the range from, let's say, 10 to 20. Okay, where our x min would be 10 and our x max would be 20. For the y values, if we look here, for the smallest value that we see, it's probably going to be, let's see, this one here. So 28.8. I don't see anything smaller than that. So we have 28.8 is the smallest. The largest would be probably 50.1. So a good range here would be from 25 to, let's say, we need to go a little bit past 50. So let's just say 55. Okay. And so that tells us what we need to put here in our window. So instead of having the standard window of -10 and 10 for the x min and x max, and y min and y max, we want to go ahead and change it to these values. So we'll come over here and do that now. So here we'll go from, let's see. Okay, so let's go ahead and enter in those values. So I think for the x values, we said that we were going from 10, oops, let's try that again, from 10 to 20. And we'll skip the x scale, which just means the divisions of one unit there. And we'll move on to y min, which in this case, we'll go from 25 to 55. Okay. And so now when we graph, we see that we actually have a graph there. And so if you're looking at a problem that says, all right, let's graph this data and figure out which graph is closest to it, then of course you would just look at this particular graph and compare. Now, if we wanted to move a little further here and say, okay, well, we have this data here and we need to find the line that best describes how this data is going to act, or as an estimate, we call it a best fit curve. We see that the points aren't necessarily in a straight line, but if we were doing linear regression to kind of give us an idea of the direction of how the data is going, then from there what we would do is do the following. So first we want to still make sure that we go to stat. And so now with our data that's in the edit part, we want to actually do something with it. So we're going to go to calculate. And then here you have all these different type functions here. So number 4 is the one that I'm going to use, which is the linreg, or linear regression. Okay. And this form of linear regression allows our A to be the slope and our B to be the y-intercept. We do have another form down here where the A is the y-intercept and the B is the slope. So if you use either one of these, 4 or 8, to do linear regression, then please make sure that you know which variable you are interpreting to be the slope and which one you are interpreting to be the y-intercept. If you also notice here that in this list you have quad reg, means for quadratic regression. You have cubic reg, meaning cubic regression. Quartic reg, which means for a polynomial raised to the 4th. You also have linreg, or natural log reg. And you have exp reg, which means you're trying to model something that looks most like an exponential function. Power reg, you're trying to model it as a power function. And you also have logistics and sin reg, which is trying to model it to a sinusoidal function. Okay. So here again, we're just going to do linreg number 4. So we just do that. And then from there, we're going to tell the calculator that, hey, we want you to graph this in the same graph area as we have our scatter plot. So how we're going to do that is call the columns in which we had our x and y values and tell it where to go. So the first thing is we'll call the x value, or the x list, which is going to be L1. So we say second, the number 1 for L1. We hit our comma, and then we know our y values are in L2. So second, the number 2 for L2, comma. And then the last thing that we need to do is tell it where to actually plot. And we want it to plot in Y1. So what we're going to do here is go to vars, and then go to yvars. And then after that, we're going to go to function. So press number 1. And then we're going to tell it, hey, let's do in Y1. And so then from there, we hit enter. It gives us these values here. And if we go to graph, we see that our line has been drawn. Okay. And so basically what the line is trying to tell us is that we have, although it's very loose, we have negative correlation with the data. So that means as the X values get larger, the Y values in general tend to get small. And so this concludes the video on how to enter in data into your calculator to be able to graph a scatter plot as well as do linear regression.